The slip of an induction motor can be found out by this equation. That is, the slip of an motor will be equal to the subtraction of actual rotor speed from the synchronous speed ns, and the result will be divided by the synchronous speed of the motor, and then that will be multiplied by 100. Besides, synchronous speed ns is equal to the multiplication of 120 and supply frequency, and that will be divided by the number of poles in the motor. Besides, at any slip speed, the frequency of rotor current will be equal to the multiplication of two quantity, slip and supply frequency. At running condition, induced EMF per rotor phase will be equal to the multiplication of slip and standstill rotor induced EMF per phase. Besides, rotor reactance per phase under running condition will be equal to the multiplication of slip and standstill rotor reactance. We may know it, starting torque divided by maximum torque will be equal to twice A by 1 plus A square, where A is the ratio of rotor resistance and standstill reactance per phase. Rotor gross output is obtained by subtracting rotor copper loss from rotor input current. And rotor copper loss is equal to the multiplication of slip and rotor input power. So we are getting rotor gross output is equal to 1 minus the slip of induction motor, which will be multiplied by the rotor input current or the stator output current. Besides, we are getting the ratio of two quantity Pm and P2 will be equal to the ratio of other two quantity, that is actual rotor speed and the synchronous speed. So rotor efficiency will be equal to the ratio of two quantity, actual rotor speed and the synchronous speed. We can also get the relation between copper loss, slip and rotor gross torque. Which is copper loss will be divided by rotor gross output, and the result will be equal to the slip of the motor divided by the subtraction of slip of the motor from 1. Gross torque is obtained from the equations, and they are: rotor gross output will be divided by angular speed, or rotor input will be divided by synchronous angular speed. Or can easily be said that rotor gross output is equal to the multiplication of gross torque and angular speed, and rotor input is equal to the multiplication of gross torque and synchronous angular speed.